Welcome to Brain Vision.
Now in this question we have a skier starting off a giant snowball, right, which is frictionless, and we want to find a point at which the skier loses contact with the snowball. And at this instance we want to find what is this angle, right, alpha. So at this particular point we want to observe what is the free body diagram of our skier. So just for convenience, we're gonna assume that it's like a block, right? So at this point, the only thing that is acting on the skier is the weight. So mg, and we know that there is a component that is perpendicular to the surface that is providing the centripetal force to keep it in circular motion. So this is the component of our weight, and in this case the angle alpha is this angle within over here. This will be alpha. Now at this point it is just exactly enough to contribute to the just enough to contribute to the centripetal force. So this is mg cosine alpha must be equals to mv square over r. And we can cancel out the common m inside here to get this expression, but we still can't solve for alpha because we have an unknown v over here. What is v? Now v will depend, right, on the kinetic energy that our person has at this point, and the kinetic energy would come from the gravitational potential energy, right? So having to be at this particular point, it has converted this amount of gravitational potential energy, right, mgh, into kinetic energy, half mv squared. So g times h is equals to half v squared. So v squared is equals to 2gh. And what is h? Well, we can find h in terms of alpha. Right, remember that this distance over here, let me just call this distance x, and this distance here as x. X would be equals to, based on trigonometry, r cosine alpha. So h will be just taking r minus r cosine alpha, which is 1 minus cosine alpha. Substitute that in to this expression, we get 2g r times 1 minus cosine alpha. Now we can solve for what is alpha, right? So we just bring this expression v squared into our previous expression. We should get 2g 1 minus cosine alpha. We rearrange a bit, so from here we get negative 2g cosine alpha. We bring it to the left hand side to be 3g cosine alpha is equals to 2g So cosine alpha is equals to 2/3, and finally alpha is 48.5.